All right, here we go, more unit circle fun. The examples that we will look at today will be a little bit more complicated. We'll bring into play angles that are not between 0 and 360 or 0 and 2 pi. And we will also look at the reciprocal functions, secant, cosecant, and cotangent. So our four rules are still going to apply here. We want to identify reference angle. We want to identify the coordinate that's associated with that reference angle, the quadrant the angle is located in, and the ratio. The order in which you do these is really irrelevant, but these are the thoughts that should be going through your head. You can also have your handy-dandy unit circle out to help you through these examples. However, again, the goal is for you to be able to do these without referring to the unit circle, if possible. So, sine of 510 degrees, not between 0 and 360. So what we're going to need to do is subtract 360 from 510. All right, so if we just subtract 360, this will get us more comfortable with the angle. We'd have the sine of 150 degrees. Okay, 150 degrees is a 30-degree reference angle. It's in quadrant 2. Okay, so its coordinate pair for a 30-degree reference angle would be plus or minus root 3 over 2, plus or minus 1/2. And since 150 is located in quadrant 2, we know the coordinates in quadrant 2 are negative and positive. Since we're dealing with sine, we're going to use the y coordinate there. And because we are in quadrant 2, the y coordinate's positive, our answer is going to be 1/2. And that can be confirmed right here. Okay. So there's our first one. Second one, the cosine of 23 pi over 6. Again, 23 pi over 6, not on, or not between 0 and 2 pi. So we can work with that by subtracting 2 pi. If we do 23 pi over 6 minus 2 pi with a denominator of 6 is 12 pi over 6. Okay, 12 pi over 6 would reduce to 2 pi. So this will become 11 pi over 6. So it just becomes easier for us to identify what to use here. We're just going to find the cosine of 11 pi over 6. All right, again, 23 pi over 6, 11 pi over 6 are coterminal angles. So this is getting it down to a problem that was in the previous video. That's really what our goal is. Okay, so as we go through our four-step process here, this is again a 30-degree reference angle. All right, so it's going to have the same coordinates that we have here, but 11 pi over 6 is located in quadrant 4. Okay, quadrant 4's coordinates are positive, negative. Since we are dealing with the cosine, we're going to utilize the x coordinate, and as I just stated, we're in quadrant 4, that x coordinate is going to be positive. So our answer here is going to be root 3 over 2, which again can be confirmed right here. Okay. All right, we could also have angles that are negative. So in this case, negative 2 pi over 3, not between 0 and 2 pi. We're going to take negative 2 pi over 3 and add 2 pi to that. 2 pi with a denominator of 3 would be 6 pi over 3. Okay, 6 pi over 3 would reduce to 2 pi. So when we do this, we're going to end up getting 4 pi over 3. So we're going to want to find the tangent of 4 pi over 3. Okay, this is a 60-degree reference angle. With a 60-degree reference angle, all right, a tangent will have a value of either plus or minus root 3. Okay, so again, that's something that you should commit to memory. We just have to decide if that's going to be positive or negative. The angle 4 pi over 3 is located in quadrant 3. Okay, so we can kind of confirm that here just by looking. 4 pi over 3 is in quadrant 3. In quadrant 3, this takes us back to that all students take calculus acronym. Tangent in quadrant 3 is positive, so that means we're going to utilize the positive value that we have here, and the answer would be root 3. So that's dealing with angles that are not between 0 and 2 pi, not between 0 and 360 for sine, cosine, and tangent. But what about problems where we have the reciprocal functions? So my guess is you would probably say that this is enough information here to commit to memory. All right. If I asked you to memorize the values of secant, cosecant, and cotangent, that would be doubling the amount of information. And, you know, You may have the brain power for that. I know I don't. All right, so it's just way easier for me to, instead of finding the secant of 2 pi over 3, I can use its reciprocal and find the cosine of 2 pi over 3. Okay, 2 pi over 3 is a 60-degree reference angle. It is located in quadrant 2, and I can take the x-coordinate in quadrant 2. So if we kind of cheat here a little bit, cosine 2 pi over 3, x-coordinate there is -1/2. So the cosine of 2 pi over 3 is -1/2. All right. Secant is its reciprocal. Okay. So the reciprocal of -1/2 is is -2. So that would be our answer. So secant 2 pi over 3 comes out to be -2. All right. This one does work out pretty well. So what we can do on our calculator, if we go to mode, some of these will come out to be in funky decimals, but this one won't. If we go to radian, I get a question, questions a lot, like how can we input secant into our calculator? Well, secant is equivalent to 1 over the cosine of theta. That's the way that we could say that's the reciprocal. So if we get this in radian mode, there's no secant button on the calculator, but what you can do is do 1 divided by the cosine of 2 pi over 3, because we are in radians. So I go 2 pi divided by 3, and you can see we get our answer there of -2. That one just works out to be a nice clean integer. Most of the time when you do these, you'll get some crazy funky decimal, like √3/2, where that comes out to be as a decimal. We don't want those. We want these answers to be exact. But this one works out nicely on the calculator to give us an exact value. Okay, and you can do that for cosecant and cotangent as well. You can do cosecant being 1 over sine of theta, cotangent being 1 over the tangent of theta. So these examples down here, again, I don't know the values of cosecant off the top of my head. All right, so what I can do is find the sine of -7 pi over 4. But again, -7 pi over 4 is not an angle that I'm super comfortable with, because it's not between 0 and 2 pi. All right, so that's going to be my goal. So I'm going to add 2 pi to that. So -7 pi over 4 plus 2 pi. 2 pi with the denominator of 4 would be 8 pi over 4. So that gives me pi over 4. So now I'm going to try to find the sine of pi over 4. Okay, sine of pi over 4 is equivalent to √2/2. All right, if we go back to answering our 4 questions, denominator of 4 is a 45-degree reference angle. So it'd be plus or minus √2/2, plus or minus √2/2. All right, looking here, we're dealing with sine, so it'll be a y-coordinate. And since we're in quadrant 1, it'll be the positive version. But we're not done, because we do need to take the reciprocal of this to get the cosecant. So the reciprocal of √2/2 would be 2 over √2. It'd be helpful if you could see that. We have to get the radical out of the denominator by multiplying by √2. That gives us 2 √2/2. That cancels out. So our answer is just √2. So that is equivalent to the cosecant of -7 pi over 4. Can you check that? You betcha. All right, here's how you can do it. We'll go 1 divided by the sine of -7 pi over 4. Okay. There we go. And if we take the square root of 2, notice you get the same value. So when you take an assessment here, I don't want these decimals, but it is a way for you to check your work. Okay. I want the exact answer. All right, that's what you're going to need moving forward. Okay. Cotangent of -570. All right, with that one, again, -570, not between 0 and 2 pi. So what we would do here is add 360. All right, and if we do -570 plus 360, we'll find we're still in a negative area, -210. I want to get it between 0 and positive 360, so I'm going to add 360 again, and that'll give me 150. So this will be the cotangent of 150. Okay. Again, probably don't have those values of cotangent memorized, but hopefully we'll have the values of tangent memorized, and then we can just find the reciprocal. So the tangent of 150 degrees, that's a 30-degree reference angle in quadrant 2. So since it's a 30-degree reference angle, it's going to be negative root 3 over 3 because tangent is negative in quadrant 2. All right, so you can see that here again. There's your value of tangent, negative root 3 over 3. Again, that's not our answer. We need to take the reciprocal of that. So if we take the reciprocal, we're going to multiply numerator and denominator by root 3 to get that to cancel or become a rational value in the denominator. So this will give us negative root 3 over 3, negative 3 root 3 over 3, which is just negative root 3. So there we go. All right. If we progress to some other examples that are quadrantal angles, here secant of 810 degrees. All right, that again is not between 0 and 360. So 810, what we're going to end up doing is subtracting 360 twice. So basically I'm just going to go ahead and fast forward that and subtract 720, which is subtracting 360 twice. So that gives me the secant of 90 degrees. Okay, again, I'm just going to find the cosine of 90 because I don't know the values of secant off the top of my head. This is a quadrantal. So 90 degrees is at the top of the unit circle. The coordinates are 0, 1. Cosine is going to be the x value, so that value will be 0. But we want the secant, which is the reciprocal of cosine. Reciprocal of 0 is undefined. Okay. And again, if you put that into your calculator, you would do you could type it in 1 over cosine of 810 and you should get an undefined value. All right. That check trick also would work for problems like these. Okay, so you can type in, if you're in degree mode, I'll just do this real fast, just for fun. If I toggle back to degree mode, all right, and I enter in the sine of 510, we can see there I get 0.5. That matches. Okay, if I toggle back to radian mode, okay, and I do the cosine of 23 pi over 6, you'll see I get a funky decimal. That funky decimal hopefully is equivalent to the square root of 3 divided by 2. There you go. Okay. So again, easy way to check. Utilize in your calculator. The cotangent of 6 pi would be 3 revolutions around the unit circle. So you could, we know 1 revolution is 2 pi. So if this was 2 pi, 4 pi, 6 pi, bottom line is we're going to end up here. But if you wanted to subtract 2 pi 3 times, bottom line is you're ending up at the same spot as a 0 degree angle. The coordinates here are 1, 0. All right. So for this quadrantal, you could view it 2 ways. If you want to find the tangent of 6 pi, that's fine. Tangent, again, is the y over the x. So that would be 0. Reciprocal of 0 is undefined. So there we have undefined yet again. However, if you do remember that cotangent and tangent are reciprocals, if tangent is y over x, cotangent would have to be x over y. So that would be 1 over 0, which would still lead us to undefined. Okay. Secant of negative 3 pi, if you want to get that angle to be positive, you add 2 pi, it's still not positive, add 2 pi again, you're going to get pi. So you can find the secant of pi. Pi is located over here on the left side of the unit circle. Coordinates are negative 1 and 0. You can find the cosine of pi, that's the x coordinate, which is negative 1, and the reciprocal of negative 1 is negative 1. So our answer here would be negative 1.